All right, welcome back. So after doing the last three videos, I wanted to do a module that I'm calling Too Fast, Go Back. So maybe you went through the first few videos and you said, well, great, I get this. In that case, feel free to just move on to the next set as they become available. But if you're an absolute beginner or somebody that's not coded a lot or even just want to review some of the key concepts, you may have felt like, wait, I missed that. These videos went too fast. And so at the end of this section now, I want to go through and just review what we've learned, talk over a few fundamental concepts, and kind of go back, dig into the topics a little bit more. So if you're a true absolute beginner to coding, I thought maybe we'd go over quickly just the three key parts of a computer so that we understand some of the terminology and what's going on. There's basically three key things to think. First, there's the hard drive, which has permanent file storage, right? So here's where we're going to store our files, right? These could be text files, they could be raw files, they could be whatever. But the key thing is that when we shut off the computer, they're still there. Now, memory is the temporary file storage, or temporary storage, if I should say, all kinds of information. And that's something that's basically, if you turn off the computer, it disappears. It's only very temporary. But it does let you, it's where like all the fast, quick operations go. This is where we store things like variables and functions and all of that. And then the processor is just the device in the computer that's going to go back and forth between these different things. It lets you read from the hard drive, it lets you write to the memory, it lets you do various operations. And that's where I put down here what are kind of the four basic operations of the processor. And this is really where our computer code is going to operate. So one of the basic operations is that it can read data either from the memory or from the hard drive. It can do processes, and actually the processes that the computer can do, that the processor can do, are actually very simple. It really boils down to basic arithmetic and logic, right? So it can do addition, subtraction, multiplication. It can do comparisons. Is this one greater than this? Is this equal to this? But really all other operations, all the fancy Fourier transforms and you know, really complicated operations, it all boils down to basically computer code that is operating a series of very simple operations. So the other two operations, in addition to processing and input, are output. So this is basically displaying or presenting data to the user. So a lot of times you'll see when I code, I'll do print, right? That's a form of just like outputting some information to the user. And finally, there's storing. And this involves writing data either to the memory or to the hard drive. And so these are really the four basic operations. So the processor is actually very simple. What makes it useful and amazing is that we can add on layers and layers and layers of computer code. And basically at the most basic layer, the computer code is going to be doing one of these four basic operations. But then on top of that, we build various different tools, and that allows us to do very sophisticated things very quickly. And so computer code is basically just a typically linear set of operations that the computer is going to perform. In Python in general, maybe in a future video, but in general in all of these videos we're going to be doing linear programming, meaning that we're going to start with line 1 and the computer is going to execute line 1, it's going to execute line 2, line 3, line 4, and it's just going to go down. And so if you want to understand what it's doing, you just start at the top and you just think like a computer and read straight down. Now, there are ways you can do things called parallel processing. So many modern processors and graphics card, which are just a type of processor, have multiple cores, meaning that they have multiple processors built into one unit. If that happens, what it means is we can do something called parallel processing, where we take a simple set of or a complex set of operations, and rather than just doing one at a time, we divide them up and do a few in parallel. We're probably not going to talk about that for a while. So just assume now that we're going top to bottom in a linear order. We're going to do A, then B, then C, right? Okay, so that's kind of the process to think about coding, right? It's just a series of simple operations that's either inputting, outputting, storing, or processing, right? Doing some sort of arithmetic or logic. Now, within Python, there's a series of different types of objects, and this is really critical language to learn. Because it really helps think about what's going on. So first there are variables, and that is data that's stored in the memory. There are lots of different types of variables, and so you can have floats, which are basically decimal place, 3.0, 3.2, right, things like that. You can have integers, which are basically just integer values, right? These are slightly different in terms of how the processor stores them and how it handles the math. You also have things like strings, which are just a set of characters, right? This is text. There are Boolean objects, which basically are just true, false, right? These are actually just at their basic stored as integers that are either 0 or 1. Not exactly, but close enough. Then there are also things like lists or arrays, and we'll go over, there's slight differences between a pure list and a numpy array, which is a slightly different object, but they're basically the same. They're just collections of objects, and they can be collections in either one-dimensional, like we've shown here, 0, 1, 2, and this would be a list of integers, right? We could, of course, have a list of floats or a list of strings. Or we could have multi-dimensional lists and arrays, and that's where when we start getting into multi-dimensional objects, we want to try and use probably arrays, which are a little bit more versatile than lists for that purpose. Finally, there's an object in Python that we'll talk about later, which is a dictionary, where you basically have a keyword and then a value, right? So we could say, oh, the name is Python champion, and of course, there's actually lots of other data structures in Python. But this is just a set of different variables that we can think about, and we'll see some of these in what we've done today. In addition to variables, there are also functions, and functions are basically exactly like the mathematical functions you would have learned about in algebra, right? We have some sort of input, we have some sort of output, and then some sort of operation, right? So we might say add, which would basically be like add these two numbers, A and B. You saw us using plot, right, where we put in an X value and a Y value, right? When you call plot, it's just doing a series of operations, and then oftentimes, but not always, they'll return some sort of output. So in the case of add, you could return the addition of those two numbers, right? And we'll talk a little bit more about how to write functions in the future. The final thing I'll just briefly mention is that there's another type of another type of structure in Python called a class. And a class basically is just a collection of variables and functions and also subclasses that you can have. And it just groups them together, right? And so this is a way of just collecting our data and our information and our functions in a way that lets us pass them very quickly and be very flexible in the way we code. So you'll see some examples of this. Really, actually, a lot of things in Python are classes, like even strings are classes, even though we would call them variables, but there are functions that we can use within that string class. You'll see this later as we go. If this doesn't make sense, that's okay. It's actually a relatively new concept in computer programming. Like a lot of early languages just had functions and variables, and it was when people developed object-oriented language, this is what this is called, where we have classes, right, that you can basically group these functions and variables together into objects that then you can pass back and forth. And one of kind of the meta sets of a class is a library or a package. And this is something where basically we have a collection of different variables, functions, and classes all grouped together into one structure that allows us then to import it. And this is what we were doing in that second and third video, where we were importing different classes like different libraries or packages like NumPy or matplotlib. So with all of those kind of basic terminologies established, let's go back and take a brief look and just kind of walk through and think about these different functions that we wrote. So we first started with this test file in our first video, right? And you can see we have A equals 2, B equals 3, C equals A plus B, and we said print the answer is C, right? So you can see here we have a handful of things going on. First, we have a test.py file, and that's written to the hard drive. So that's actually a physical file that lives in the hard drive. If we shut off the computer, which I have done over the weekend, you can come back and you can reload that file. Inside that file is a series of computer code, so it's just a series of operations. The first is to say create a variable called A, right? And set the A variable to 2. So we're setting A as an integer 2. B, we're setting to 3, same sort of idea. And then we're creating a third variable, C, that is just the product of A plus B, right? And of course, here we have memory setting. This is memory setting and an arithmetic operation, right? And then finally, we do a print command, which is just printing to the console out and saying the answer is, and we're printing the variable C, right? That is an output operation. You can see we haven't written or read anything from the hard drive. This is all memory, except for the overall file itself, right? But we're not reading any data from the hard drive. We're not writing any data to the hard drive. We're just writing from the code to memory and then printing to the output, which is also in memory. So, you know, if we run this, you saw before that we're going to get the answer is C. Now, of course, we could write a function to do this, and this is where we would use syntax like def add. So define a function, and the function's name is add, and the inputs would be, let's call them X and Y, just so we don't get confused. And then we put a colon to say this is what we're going to do in that function. And then you can see it's automatically indenting. Indenting basically is the way of telling it what goes in that function. So we could say then z equals x plus y, and then say return z. So return is basically saying this is what the output of the function is. So then to call that function, we could say d equals add a, b. So here, d is our, sorry, it wants an extra line there. There we go. D is a variable, right? Add is saying run this function that we've defined, which is add. And A is one of the inputs, B is another one of the inputs, and the output, Z, is going to be stored as D. So then if we switch this, we could say print D. Let's go ahead and run this. The answer is 5, right? And the cool thing here is that we could put in different things. So we could say A plus 1 rather than A. And this should be 6 now. There we go. All right, so this is how we use functions. And we're not really going to go too far into classes today. But hopefully that explains some of what we're doing here, kind of on a very basic level. So let's take now a look at our file plotter. So again, this is, you know, 20 lines of code, but we can just start from the top and just read it all the way down. So first, we're importing the NumPy library, right? NumPy, again, is numerical Python, right? And so it allows us to use arrays and to do different objects on the arrays and do different mathematical operations. You can see some of here, all the things and some links as we go in at what NumPy does. And so we're importing the NumPy and we're calling it NP. So we're actually creating a variable that stores the entire package. And so that variable is NP, right? And what it means is that we can access, and again, the package is a class. So within NumPy, we have functions, we have variables, we have other subclasses. So with that NumPy variable, we can now access all of those different variables and functions and classes inside of there. We've done the same on the second line with matplotlib, right? Matplotlib, which if I highlight here, it's not going to do as much cool stuff. Matplotlib, there we go. Okay, it's a plotting language, right? So it's basically, sorry, a plotting library. So it's a package that lets us make plots and operate with them in different ways. And so what we're doing is basically importing actually a specific subclass or subpackage within matplotlib called pyplot. And this is just a very simple way to do plotting operations. You can see it's actually modeled after MATLAB. And what we're doing is we're importing from the big package, we're importing this subpackage, and we're saving that as a variable called plot, right? So basically this just sets up all the libraries that we need to run all the code. So next we have the path, right? And this is basically saying on the hard drive, where should we look for this particular file? So we want to remember on this one, we're reading a file from the hard drive. So this just tells us on the hard drive where it is. And of course, you'll be familiar with using things on the hard drive. We have basically folders or directories, and then we have files themselves. And so this is basically saying the whole path, including all the folders, and then the file name itself. So after we tell it what the path is, and of course we're setting the path variable as this string, right? Just a series of text. That's going to be all of this. Now you might wonder why we put in double backslashes here, and that's because the backslash character is actually used for things like new lines or tabs, like Control N is a new line, Control T is a tab. And so if we had something like text, you can see it would actually put a tab in, which is really annoying. And so in general, in Windows computers, you need to use a double backslash in file names. So just be aware of that. Okay, so let's take a look. Now we're going to use a function from the NumPy library. So within NumPy, there's a function called load text. You can see it's going to pull in our documentation here. And the load text basically says, what's our file name, right, which is here. And then there's lots of different various like other inputs that we can include. And then the nice thing in Python is that some of these are required and some of these are optional, right? So it's required that we tell it what what file we want to open, but it's optional that we can add in something like skip rows. And what skip rows does is basically just says, as it reads down the file, right, each file has a set of lines, skip the first n rows. And in this case, we saw on our data that the way that Qual Browser saved it was with a bunch of header text, and we didn't really need that. So we basically just said skip those 8 first rows, jump right into reading the data. And numpy load text is basically a function that will take in the file name, find that file, read all of that data in, and put it in an array. And what we get is a variable called data, which we've saved it to, that now is an array. You can see the data is an array object, right? And so once we have that array, we can parse it in different ways. And we kind of talked a little bit about this in the video by putting on brackets that's saying take a subset of that data, right? Because we have a list, it's actually a 2-dimensional array where we have, x, y, x, y, x, y, x, y. So by basically putting the colon, by putting the colon here, we're saying take all of the first dimension, but only the first point in the second dimension, the 0th point. Remember, we're starting from 0 and counting up. The y data is going to be the opposite, so we're going to take all of the data and just take the the second column, right? And this basically just says, from this array, slice it so that we're getting these 2 subarrays, right? And we're going to save those as variables called x and y. And then we're doing some mathematical operations. So basically, ymax is a variable that we're going to use this function amax. Amax stands for array max, so we basically feed it in the y. You can see here some documentation when we hold it up. Basically, it's going to return the maximum value of an array along a given axis. And here there's only one axis, so it's just going to return the maximum value of the y array. So then we're going to basically say, okay, do an operation, take all of the data in that array, divide it by the ymax, multiply all of those by 100. So basically, in the background, what it's doing is it's saying take the first element, divide it by the max, multiply it by 100, take the second element, divide it by the max, multiply it by 100, loop through that entire array, and save that now back into the original variable y. So that now sets us up where we have our data that's processed, and we can do our plotting operations. And so we're going to use a series of functions from the matplotlib library now, where we basically say plot the data, which is x and y. Let's put on an x label, and we're giving it a string saying m over z. We're going to say add a y label, which is intensity and percent, and then we can save the figure, which is of course going to write it now to the hard drive, and then we're going to show the figure, which is going to display it to the user, right? And so all of these things are doing basically one of those 4 basic operations just in a top to bottom list. And so you'll notice that we've done save figure before show, and that's because we want to save the figure before we show it to the user. We could flip those, but what it'll mean is that it'll pop up the display, and until we close the display, it won't actually save the figure, which is kind of interesting. The other thing I want to talk about briefly is you'll notice we use this dot as a way to access. That's basically our way of calling something within a class, right? So this is basically saying within the plot library, which is actually a variable, so we've saved the entire package as a variable called PLT. If we put on a dot, that now lets us access variables and functions. And there's actually, within there can be subclasses, so we could say plot.access.something, right? So there's different layers of operations, and that dot basically lets us get down into there. Of course, the parentheses are our hint that we're calling a function. And then anytime we use brackets, that's basically parsing some sort of array or list. So hopefully, I realize this is a bit longer video than I usually like to make, but hopefully that gives you some of the background, and if you're confused on what's going on, hopefully this fills in some of that. Of course, feel free to reach out with any questions, put the comments in the comment box if you have questions so that I can answer and other people can see. But hopefully this is useful, and feel free to send suggestions also on what to do on our next set of lessons. Thanks.